This video has one objective. You should be able to assign oxidation numbers to elements and elements within compounds by the time we are done. There are rules for assigning oxidation numbers. If you cannot do this, you cannot tell what's being oxidized and what's being reduced because you won't know what went up and what went down. Okay? So we need to be able to assign them. So here's the rules. Rule number 1. Elements are always 0. Like copper is 0. Oxygen is 0. Fe is 0, right? Now, make sure, now those are if I'm saying iron, or if I'm saying copper. If I say a copper ion, that's not the same thing. So here, if I do this, I say I have a copper ion, it's got a charge, but they can't really try to trick you. Now, this, by the way, is a charge, just nitpicky thing. Oxidation numbers have the plus or minus in front of them first. Won't affect really anything for you, okay? However, let's talk about this. This right here, okay, is blue and dissolved in water. This right here is red and it's solid and it's shining and they make pennies out of it. They are not the same thing, okay? So if they say copper, they mean this one. If they say copper ion, they're going to have to say copper 1 or copper 2 and tell you it's an ion. They can't be tricky or something, okay? So elements are always 0. That's rule number 1. Sorry if I overemphasize that, but students always struggle with it for some reason. Okay, compounds are always 0. Pi atomics are equal to the charge. And what I mean by that, okay, let's take an example of what we learned earlier. 2 compounds, sodium chloride, which is NaCl, and calcium chloride, CaCl2. Now, you should have been able to figure out those formulas, but I'm trying to go reasonably fast in the video, right? But think about this. The sodium, group 1, is +1. The chloride is -1. 1 plus -1 equals 0. So in a compound, the oxidation numbers add up to 0. In calcium chloride, the calcium is +2. It's an alkaline earth metal. And there's 2 chlorides, each of which is -1. And 2 times -1 is -2. And -2 plus +2 is also equal to 0. So the oxidation numbers always add up to 0 in a compound. Now, in a polyatomic ion, the oxidation numbers are not going to equal to 0 because the overall thing has a charge. So this is a nitrate. It's got a charge of -1, which means all of the oxidation numbers in this compound are going to add up to -1. And we'll get to that later. All right. There are certain ions, certain things you're always going to know that are going to let you figure out things that you don't know. Okay? So, in a compound, not as elements by themselves, an alkali metal will always be +1 in a compound. And there's no exceptions to that. Alkali earth metals will always be +2. No exceptions. Fluoride, that's a fluorine ion, will always be -1. Aluminum will always be +3. Now the other halogens, when they form halides, will also always be -1. But be careful with this, okay? In NaCl, right, the chloride is -1. Okay, so it would, bromide would be -1 and iodide would be -1. However, in, let's see, NaClO3, this chlorine is not -1. Notice I said chlorine, not chloride. Why? Because it's in a polyatomic ion. This is a chlorate polyatomic ion, and a lot of times they'll ask you to figure this one out, and it will not be -1. It could be, but it probably actually isn't. Okay? Okay, with those rules, we can go on to the next rule. Watch this. Ready? See if you try to remember this, right? Because I would even write these rules down and pause before you get to the next section. Okay? All right. Here's the problem. You've got 2 elements that are usually something, and usually means there's lots of exceptions. So let's start with hydrogen. Hydrogen is usually +1. Now I'm going to start with an example where it is +1, right? Now, I haven't said anything about carbon yet, right? There's no rule for carbon at all. But I can use the rule for hydrogen to figure out what carbon is. So let's say you have methane, right? CH4, right? Now, it's very simple math. I'm going to go equals 0, right? If the hydrogen is +1, right? And there's 4 of them, and I've got 1 carbon, X is my carbon's oxidation number, right? And I'm going really slow. If you're already ahead of me, that's great, okay? And I've got 4 hydrogens, each of which is +1. Well, what's X equal to? Well, I'm hoping that you don't need to break out your calculator for this. 4 times 1 is 4, and you subtract 4 from both sides, so you end up with X equals -4. So the oxidation number of the carbon is negative. Sorry, I just messed up there. Okay. There we go. Is -4. Okay. Here, let's do another one. Okay. Let's say you have N2H6, right? Right now you have two N's. Now here's the thing. I did this on purpose because you're going to do it this way. You're going to be like N is X, but there's two of them. So I'm going to go 2X, okay, plus. Now each of my H's is +1, okay? So I go plus 6 times 1, which is +6. I hope you're okay with me going 1 times 6 in my head, is equal to 0. And then I solve for X, right? And so what's X equal to? Well, I subtract the 6 from both sides and divide by 2, so I get X is equal to -3. Okay. Now, these are where the hydrogen is doing what's supposed to do. But if, let's say, something from a previous rule supersedes, like let's say there's an alkali metal or alkali earth with the hydrogen, then things are going to be different. Watch how this works out, okay? Let's say you had sodium hydride. Now, here's the thing. The rule for sodium is on the previous page, so we know sodium has to be +1. Now, I'm not going to write out the math there. If the Na is +1, the compound has to be neutral. What does the charge on the hydrogen have to be? Well, it has to be -1, doesn't it? Now, these are called metal hydrides. Metal hydrides, the hydrogen is always going to be -1. So, right? So if you have, let's say, CaH2, the calcium has to be +2, so the hydrogen has to be -1. Okay? Everybody okay so far, I hope. All right? So hydrogens are usually +1, but not when they're with metals. If they come second, they're going to be -1. You can memorize that, or you can just remember the rules for sodium and calcium and figure it out each time. Now, oxygen, this is even more annoying, is often, right, -2. Okay? So what does that mean? It's usually -2. Okay? However, if it's in a compound with these guys, again, that can throw things off. So let's start with ones where oxygen is -2, right? Like water. This works out fine. See, the water, so hydrogen rule comes first. We have two H's, each of which are +1. So you have 2 times 1 plus X equals 0. That works out fine because when you solve for X, you get X is equal to -2. Everything is nice and good, right? If you have like OF2, now you have a problem. Why? Because the fluorine is -1. That's fluoride. It's -1 every time. So now you have X -2 is equal to 0. So in this case, oxygen is +2. And by the way, this is the only time oxygen is ever positive. Because fluorine is because the one, when they have a covalent bond, the one that has a higher electronegativity will always get the negative oxidation number. And there's only one element that's more electronegative than the oxygen, and that's fluorine. All right. What are some other things where you see exceptions? Things like this. These are called peroxides, okay? So I'll do two of them, H2O2 and Na2O2. In both these cases, the rules for H and Na take precedent over the oxygen rule. So the H's are both +1 here, right? I'm not going to do the math here. You should do this now. 2 times 1, right? So if there's two +1 hydrogens, each of the oxygens has to be -1. And that's the same thing. In peroxides, the oxygen is going to be -1. All right, here's what we have to do now. We have to do some example problems. So let's set those up, okay? And yes, I know these videos are a little longer than usual, but whenever it's a math skill, I feel like I have to go a bit slower. So what I'm going to do now is I'm going to do some practice on some ones that look a little more complicated, but it's really not that bad because what you're going to find is if there's two elements in there, there's going to be two, or let's say there's 3 elements, you're going to know 2 out of the 3 and have to figure out the third one. If there's 2 elements, you're going to know 1 out of the 2. All right. So let's start with KClO3, right? It seems more difficult, but here's what we know. We know the K is +1. And this is not a chloride, right? So the Cl is not -1. We actually don't know what the Cl is, but we do know what the oxygens are. They're each -2, because in a compound, oxygen is going to be -2 with a few exceptions, okay? And that's only when you see it with like in what's called a peroxide or OF2. So oxygen is usually -2. So now you can go with that. You have 1 plus X minus, now there's 3 of the oxygens, so the overall all the oxidation numbers combined are -6. Each oxygen is -2 in here, and that's equal to 0. So when you do the math, you end up with x is equal to, okay, plus 5, right? And notice if you put a 5, 1 plus 5 minus 6 is 0, right? Now in a pi atomic ion, they're going to equal the charge. So in this one, SO4, you have S is your X. You have, now this 2 minus is not telling you what oxygen's oxidation number is. It's telling you that the pi atomic ion is a charge of -2, right? So be careful about that. So you have 4 oxygens, each of which has an oxidation number of -2. So it's X minus 8, but that's equal to -2. So when you solve this, you get X is equal to +6. Now what's interesting is no matter where you see a sulfate, which is what this is a sulfate, okay? The sulfur and sulfate will always be +6. It doesn't matter where you see it, you know it automatically, right? We can solve that later. I'm going to do it down below on the page, but that's just a fact now, okay? In a sulfate, S is +6, period, okay? A Cl and a chlorate is always +5. Anytime you see ClO3 in there, it's +5. Let's try KMnO4. The K again is 1. We don't know what Mn is, but we do know that 4 oxygens add to -8, and that's equal to 0, which means in this case X is equal to +7. In C2H6, we have 6 hydrogens. We know each of them is +1. We have 2 carbons. We're doing 2X plus 6 equals 0, which means each of my carbons, okay, has to be equal to X is equal to -3. So there's 2 -3 carbons and 6 + 1 hydrogen. Again, it adds up to 0. Okay, let's look at H2S4. That's sulfuric acid. Now, sulfuric acid has a sulfate in there, doesn't it? Okay, let's assume we did know that sulfur is +6. Let's prove it, okay? We know the hydrogens are +1. We know each of the oxygens is -2. So we have 2 times 1, or 2, plus X minus 8. And this is a compound, so it's neutral. It adds up to 0, right? So what's X equal? Well, 2 plus X minus 8 equals 0. X is equal to +6, just like we expected. So even if it's in a compound, if you see a sulfate, the sulfur is +6. Now the last one here is CaCr2O7, okay? And then what I'm going to do is I'm going to put like 2 or 3 more up for you to try to do on your own, and I'm just going to then plop the answers up there without an explanation, okay? Now we know the calcium is +2 because it's an alkaline earth metal. We don't know what the chromium is, so we're going to write 2X for that. We have 7 oxygens, that's -14, and that's all equal to 0 because this is a compound, right? So we're just going to combine some of my terms. We end up with 2X minus 12 is equal to 0, and therefore the X is equal to +6. All right? I hope that helps. Here's some extra practice. So here's the sample problems. I'm going to pause and do the work, and I'll put the work up. So these are the answers. I just pointing out this one right here is usually the tough one, the one right over here. You have to realize there's 2 chlorines in there and there's 4 oxygens in there. So that makes the math a little bit difficult. Be very aware of those parentheses. They can confuse you. I hope this helps.